Here we come to the example of page 30. So we have an experiment on the circular motion with a swinging of a rubber band, which is connected to a glass tube through a string to the mass M, capital letter M. So the rubber band will be swinging in circles, and it will be pulled to the center by the tension inside the string. First of all, part A, we are going to find the tension Ft in the string. So how can we know the Ft? We have to consider at this point. At this point, the mass big M is acted on by the gravitational force mg, and also it is acted on upwards by the tension Ft. So Ft is basically equals to mg because the mass M has not gone up or down. Mass of big M is 1 kg, G is 9.81, so the tension in the string would be 9.81 Newton. Part B, how would theta and omega of the rubber band change if L decrease? That means if I use shorter section of the string, I let the string to shrink inside. What happens if so to the angle and omega? First of all, we have an equation governing the angle. Angle cosine theta is equals to small m divided by big M. So there is nothing to do with the length of string L. So theta is independent of L. Therefore, theta is unchanged. On the other hand, because we have another equation Ft equals ml omega square, if L decrease, omega, while keeping others constant, omega will increase. Therefore, angular speed is increased. It would go faster. Part C, it takes less than 1 second for rubber band to complete one revolution. Suggest how the angular speed omega could be measured accurately. Like in order to measure the time interval of less than 1 second, it is very difficult. So therefore, we can measure the time for more revolutions. Like we measure the time taken for 50 revolutions, and then we divide the time by 50. So you got the time for one revolution. Hence, because we are measuring a longer period of time, so the percentage error in measurement could be reduced because the base is larger. Therefore, the measurement will be more accurate. Part D, as students measure the angular speed omega for different length L, keeping the mass M constant. And so I would like to verify the equation T equals M omega square L by plotting a suitable graph. Okay, so which quantities should we use as the axis? So we have the equation T equals M omega square L. I want to find a relation between omega square and L. Okay, so I will put omega as the subject. So we change the equations a little bit. Omega square would be equals to T over M times 1 over L. So now we are measuring the omega for different L. So L is the independent variable. You varies the length L, make different L. And then omega would be the dependent variable. That is for your measurement. So here, in order to verify this equation, we can put omega squared on the y-axis. And then we have 1 over L on the x-axis. By this case, we should get a straight line curve under omega squared versus 1 over L, and of course T over M should be